Okay, so we're doing exercise 3, sorry, doing question 3 from exercise 10F in the first year mechanics textbook. So I've got a pulley system. I'm told the masses of the two particles that are hanging over the pulley. I'm not told the mass of particle A, but I am told that m is greater than 3. So that means I do know that the mass of particle A is greater than the mass of particle B. So when we release these pulleys, A is going to drop down and B is going to get pulled up. It's a light and extensible string. So if it's an extensible, they're going to travel with the same acceleration, obviously opposite directions. The fact that it's light means that the tension will be the same throughout. It's a smooth pulley, so there's no friction. And I'm given some information about the starting position of A. Okay, so the first thing it asks is about acceleration. So that could be using F equals ma, or it could be suvat. And if you start on the wrong track, it won't matter because you'll probably be doing working that's going to be relevant later in the question. But actually, to get the acceleration, it is suvat to start with. So they give me some information about the motion of A. And although the question asks for the acceleration of B as it ascends, so as B goes up, that's going to be exactly the same as the acceleration of A as it descends. And they've given me information about how long it takes particle A to travel 2.5 meters. So I'm really looking at particle A, but the acceleration of particle A downwards is going to be the same as the acceleration of particle B upwards. And as this is a show that question, I really should make a note that I've acknowledged that. So the acceleration of A downwards is going to be the same as the acceleration of B. Oops, that looks nothing like an arrow. Let's try that again. Acceleration of B upwards. Okay, so what information do they give me? So for A, I'm taking down as positive. So it starts at rest. It's 2.5 meters to the floor, and I'm taking down as positive, so that's positive 2.5. T is a scalar, and that's takes 1.25 seconds for it to hit the floor, and I'm trying to find A. So I'm going to use S equals UT plus a half AT squared, so 2.5, so U is 0, so UT is 0. So it's a half times A times T squared. It is a show that question, so I'm going to just do an intermediate stage of working. So I'll work out the 0.5 times the 1.25 squared. Just want to make sure I definitely get all the working marks, because obviously they give me the answer in the question. So I just think that's plenty to convince them. So if I do 2.5, just double check it does work. Yep. So if I do 2.5 divided by 25 over 32, I get 3.2 meters a second squared, and it's a show that question. So I'm going to put a brief conclusion. Okay, all right, so then they want the tension in the string, and it's going to be the sort of tension will be the same on either side of the string. So that is going to be to involve a force diagram. So let's just do a sketch of the entire system, and then we'll look at A and B separately. So there's particle A, its weight is mg, and there's tension in the string. And that's particle A. Particle B, its weight is 3g, and there's also tension in the string. And we know that the m is greater than 3, so we know that A is moving down, which means B is going to be pulled up. Okay, so and because it's inextensible, those accelerations will be the same. Right, so what do we actually want? So it wants the tension in the string. So I'm going to look to particle B. So let's just sketch B out again. Okay, so what do I know about B? Well, I know it's, the reason I'm looking at particle B rather than particle A is I know the mass of B. I know B is 3 kilograms, so I know the weight of B is 3g. I also know that B is going to be moving upwards, and it's going to be moving up with the same acceleration that A is moving downwards. So if I use F equals ma on B, and I'm going to take up as positive, so the resultant force upwards is going to be T minus 3g, and that's going to equal 3a. So t is going to be 3a, and I know that a is 3.2 plus 3g. Okay, so I'll stick that in the calculator. And that gives me 39 newtons. Okay, I'll just double check that that is correct. Yep, 39 newtons. Okay. Right, and then another show that question, show that the value of m is 65 over 11. Okay, so now I'm going to start looking at particle A. So A, it's got the tension working upwards, it's got its weight working downwards. We know that it's accelerating down with an acceleration of 3.2. And I also now know that the tension is 39. So because the pulley is smooth and because the rope, the string is weightless, is light, I know that the tension is, both these values of T are going to be the same. So if I use F equals ma on particle A, and as particle A is moving down, I'm going to take down as positive. So the resultant downward force is mg minus t, and that equals mass times acceleration. So let's sub in. What I did there? Right, what was that? That was mg. Right. Okay. So so let's sub in the values we know. So obviously we know that g is 9.8. We know that t is 39. We know that a is 3.2. So if I minus 3.2 from 9.8, I get 6.6 m is 39. So hopefully if I do 39, yeah, lovely. If I do 39 divided by 6.6, that is 65 over 11. And again, that was a show that question. So I will just specify that I have got the final answer. Okay, so state how you have used information a string is inextensible. We've mentioned it, I won't bother writing it out, but it's that's when we use the fact that the acceleration of A, so we worked out the acceleration of A ascending, sorry, that A was at descending, so when we worked out the acceleration of A going down, because the string is inextensible, that's the same as the acceleration of B going upwards. Okay, right, and then I think there is another bit to this question, so let's carry on. Okay. So when A strikes the ground, it does not rebound and the string becomes slack. Particle B then moves freely under gravity without reaching the pulley until the string becomes taut again. Find the time between the instant which A strikes the ground and the instant when the string becomes taut again. Right. So with these questions, just got to actually think about sort of what they're describing. So, so what is this? This is part E, isn't it? Okay, so what is going to happen? So there's my pulley. So let's think about what's going to happen to those two particles. Okay, so A is going to fall until it hits the ground, and we know that that's 2.5 meters. So B is going to go up 2.5 meters. Then once A hits the ground, B is going to carry on traveling upwards, and it's going to slow down due to gravity. So at that point, it'll just be traveling under its own steam, so the rope's no longer pulling it up. So gravity will cause B to slow down until it reaches its highest point, and then it's going to start dropping again. So the string will become taut when B gets back to the position it was at when A hit the ground. So A is going to hit the ground, B is going to be up there somewhere. B is going to carry on up for a little bit. So during that part of the journey, the string will be a bit loose, it'll be slack. And then once it's stationary due to gravity, it's going to start falling back down again. And when it reaches this point again, that's when the string will become slack. That's when the string will become taut again. So actually, that is going to be when the displacement of B is 0. Yeah, when it's from that point. So if I'm going to take that as my starting point, the point where A hits the ground. So when A hits the ground, I know that the acceleration well, so I'm going to take, it doesn't really matter if I take up or down as positive, because I'm doing S is 0. So I'm going to take up as positive. So after A has hit the ground, the acceleration will just be minus g, or minus 9.8. So let's just make a note. So this, we're looking at what's happening after A has hit the ground. So the acceleration is no longer 3.2, because that was due to A pulling B up. So after A hits the ground, whilst the rope is slack, the acceleration is just due to gravity, so it's just g. I want S to be 0, because I'm trying to find out when B gets back to this point again. They are asking me how long it takes, so I'm trying to work out t. Okay, and I don't currently have any other information, so I'm going to need to go back to before A hit the ground, or the point at which A hit the ground, and if I can find the velocity that A was travelling at when it hit the ground, that will be the velocity that B was travelling at, and that will be the initial velocity for this part of my calculation. So when A hits the ground, so I'll do it in terms of particle A, but it's going to be the same if it's A or B. So taking down as positive, A was travelling with an acceleration of 3.2. Its initial velocity was 0. The ground was 2.5 meters above where it started from, so it travelled down 2.5 meters. And I also have t as well, because I know I'm thinking of the right question. Yeah, that took 1.25 seconds. So, and I am trying to find v. So I've got lots of different options actually to what I could use. So let's use v equals u plus at. So v is 0 plus 3.2 times 1.25. So v is 4 meters a second. So that's the velocity with which A hits the ground, which will also be the velocity with which B is travelling at that point. A is obviously travelling down at that point, but B is travelling up. I'm taking up as positive, so U will be positive 4. So at the moment when A hits the ground, B was travelling upwards with a velocity at 4 meters a second. So now I can use S is ut plus a half at squared. So 0 is 40 plus a half of A, and A is minus 9.8, so we'll just go straight to minus 4.9 t squared. So that's a quadratic, and actually it makes perfect sense that I'm going to get two solutions, and you're absolutely fine to put that into your calculator, but if I just factorise it, if I take t out as a common factor, I get two solutions. T is 0 and t is 4 over 4.9. And that makes perfect sense, because obviously its displacement was 0 when A hit the ground, so that is when t is 0. So that's not the one I'm interested in. I'm interested in 4 over 4.9. I shouldn't leave a decimal within a fraction, so I can either put that as 40 over 49 or give it to three significant figures, so 0.816 seconds. Okay, and let's just double check that solution. Yeah, 40 over 49. Okay, lovely.